Hey there, in this video we are going to discuss about shallow and deep copies in JavaScript. Before going ahead with how variable copying works in JavaScript, let's look at the basics, primitives and reference types. In JavaScript, we have 6 kind of data types that comes under primitive data types. Those are strings, numbers, undefined, null, boolean and symbol. And objects, arrays, functions, these kind of variables comes under reference types. Let's see the difference between them. I'm going to create a variable and assigning it a value 10 and creating another variable and copying a to it. And I'm going to override b's value to 20 and I'm going to log both of these values a, b. If you see here, a is holding the value 10 and b is updated to 20. Now let's see what happens in case of reference types. I'm going to create an object original and giving it some few key value pairs. Let's say Elise and age 30. Now I'm going to create one more variable and copying original to it, assigning it the value of original. Now I'm gonna override one of the key, that is name, to Bob, and I'm gonna log both original and copied values. Types original copied. Yes, if you see here, I just updated the second one, that is copied one, but it is reflecting in both the cases for original and copied. This is happening because when we assign original to copied, only the reference for original is shared, not an entire new copy of it is created, unlike primitive types. Whenever we are assigning it something like this in case of primitives, a new memory space for b is created and the copy of this value is assigned to it. It's an entirely new copy that is assigned. But when it comes to objects, only the reference is shared, not an entire value is created. This brings us to how to create copies for reference types. There are two kinds of copies that we talk about. One is shallow copy and the second one is deep copy. The discussion of shallow and deep copies comes in picture with nested objects. Let's say I'm gonna modify this to address and I'm adding city to it, Bengaluru, and pin code 560087. Now instead of assigning it in this way, I'm gonna use object.assign, which allows us to create shallow copies. Object.assign. For that, initially we need to give a target value. In our case, we are just copying that to a new object, so I'm gonna give only empty object as target object. And the second one is what are the objects that we want to add to the target object. Here I'm gonna add only original. So yes, this is how I have given, and if you see here, the first one, the original one, has Elise as its name, and the change that I have made to name key value pair, that is reflecting only in the copied one. This is because I am doing a shallow copy here. Let me do the similar kind of updation with let's say pin code. I'm gonna do with copy dot address dot pin code and I'm updating that to 123456. Let's see if it's reflecting in the original one. Yeah, if you see, whatever the updation that we have done to name is reflecting only in the copied one. This is because shallow copy creates a new object here, but it only copies the first level of the original structure, which are at the root level. Here, let's say name, age. But for nested objects or arrays here, it's gonna take same references. That's the reason when we make change to pin code, it's reflecting at both the places, at both in the original object as well as the copied object. this is where deep copy comes into play. A deep copy creates a completely new object including all the nested objects and arrays. This way, the copy is entirely independent of the original. Let's see how we can do that. One of the simplest but a flawed way to create deep copy is using JSON.stringify and pass. Uh, I can do something like where copy deep. I'm using JSON.stringify that converts JSON JavaScript object notation into string. And here as an input, I'm giving my original value. And this gives me a string. Now I need to pass that as well. So I'm going to use json.pass and giving the string as input. In this way, we can create a deep copy of the object. Now let's try to do the same with deep copy. I'm going to change pin code here. Copy deep dot address dot pin code equals 1 2 3 4 5 6. I'm going to comment out this shallow copy code. And yes. Now I'm going to log both original and deep copy. If you see here, the first one, the original one, has pin code as 560087. And after that, I have created a deep copy of that. And with the deep copy, I have updated pin code here. And after updation, it's just reflecting in the deep copy of it and not in the original one. This is what we mean by deep copy when it comes to nested objects. But creating deep copy in this way has few limitations as well. This cannot be done when we have functions within the object, or when we have a few special values like date or undefined, etc. It has few limitations in these cases. So one of the preferred way to do it by using a third party library. Let's say Lodash supports deep clone. This is the Lodash original documentation, and I'm going to search clone deep here. Yes. Using this function from Lodash library, we can create a deep copy of an object, and this eliminates the limitation that I have spoken about. What it does is it recursively iterate over an object and it clones value of it. If we don't want to use any third-party library, then we can create our own utility function in a recursive way which creates a deep copy of an object. That's a quick look at shallow and deep copies in JavaScript. In this video, we have seen about what are primitive types and how are they different from reference types. And later on, we have learned what are shallow copies and what are deep copies and how to create them. Whatever we have discussed in this video, I have pushed that to GitHub with a very detailed notes along with examples. And the link for these notes is in the description box below. You can have a look. Thank you and see you in the next video.